And what makes these new and unique is that the top of the cutting edge is all even. Running cross corrugation. Tear strip pieces we made. This is a device that's going to measure the strain on the load cell to tear them. So we will do this with a variety of basis weights of paper, as well as flute direction, coatings, and laminations. We'll record that data. We'll take an average of about 15 specimens. We're now going to do a basic BCT test, and we're going to see at what point these perforations on the side walls in the front fail, basically indicating how much weight they can support before they fail. Right there, we're bulging on the sides. However, clearly fully intact. Corners are starting to fail, as they would on a BCT, but very promising. The front, solid. The opposite side, same thing, excellent. 262 pounds of force has been exerted. $256 pounds of force. Side walls still intact, even though the corner has failed. The columns have failed here. The perf still reasonably intact. Excellent design box. Beautiful edge appearance. Okay, this is going to be a drop test. We have the shelf-ready package, stadium style. Inside the box we have a 2-pound ball. It's just loose, moving around with severe load shifting. We have marked the corners. What we're going to do is slide it down the table and drop it onto each corner. Eight different corners. We'll do this with several boxes, and then we'll evaluate the consistency or the results as far as how the edges hold up. There's corner 1. Failure across here. Failure across here. No failure. No failure. This is directly across the flute. This is on a diagonal, which is harder to tear. And this is 950 here. We can say we just need to increase the hold percentage here. So we raise the hold percentage coming across the flute. Put your thumbs in. pump your thumbs. And there's your part. Okay, here's a demonstration of some of the detailed testing that we are putting our PERFormaX products through to determine how well they can stand up to shipping and transport. This is your stadium style RSC with perforations across the sides and then across the front and the back. And obviously during transportation, the product itself can shift inside the carton, therefore ripping the sides prematurely. And so we can either test it with the product itself and shake it, which you'll see here in a minute, or we obviously don't always have that. We have a series of balls with different weight and diameters. Here's a 4.5 inch diameter ball that weighs 2 pounds. It's urethane. And so what we plan to do is put it inside the box, shake the carton around, and see how well it can stand up. We also have filler pads. The purpose of the filler pad is to make sure that the impact point is in the center position. If this ball's too low, I'm going to put it up at the weakest point. So I'm going to actually put a filler pad in here. And we can do this for the different size cartons that you would have. So now you have the ball inside the carton, and the strike point is in toward the middle of the box, pushing along the sidewalls. We're going to mount it on this Waverly orbital shaker, which rotates at about a 20-degree angle. We can set the number of rotations per minute, and we can also set a cycle time for a certain amount of minutes. So we'll set it for perhaps 5 minutes, and we're going to do 40 revolutions, but we can also increase that to see where failure point is. Within the movie, you will see the type of perforating rule PERFormaX was used, the 945, and for this particular test, there's 2-pound ball inside the carton. So we now have the ball inside the carton, and we're going to mount it to the orbital shaker table. You can hear the ball moving around in there, banging on the sides. Obviously more significant than what a typical load would be, but this is only 2 pounds of contents. We're set at 40 revolutions a minute, which is again probably a little more aggressive than what you would have to have. We can set the mode for a specific period of time, such as 5 minutes, and then it will just shut off automatically. We can also increase the speed significantly to make it more violent. Okay, so we run it for 5 minutes and see what kind of damage has been sustained from the inside or out. Sidewall's holding good. The back's holding well. No issues. So what I'm going to do now is double the weight. I'm going to increase it to 4 pounds. Same style carton, just like the drop test. We got a chrome ball, 3-inch ball, weighs 4 pounds. It's twice as heavy, a little smaller in diameter. Therefore, it moves around further. Clearly, with double the weight, the impact is much more violent. As you can see, the sides here starting to blow through. But even though the back is holding, notice how the diagonal, the back's falling apart rather. Notice how the diagonal is holding together. Let me come in tight on that. He also has situations sometimes where the top of a box, you have a flap that has to be bent, hold together throughout the lifetime of transport, but yet be able to be torn. So we have a product called the 763. It's a 7-tooth rule with 63% hold, and it leaves a consistent perforation. The tips of the rule are all even, and so it allows you to bend the flap like it's the top of the box, but when the time comes to detach it, it tears it off and leaves a very nice edge. Okay, this is a movie how I can take straight notched PERFormaX off a dispenser coil, come over to the Hemmold bender, put on the curving, set the stop back here to match the diameter we're looking to do, and then feed the rule through in order to make it a 5-foot coil. So we're starting to come full circle, 360. This piece is a little bigger than 5 feet, so it's going to want to be beyond 360. I just feed it underneath. Slip it under the bender. Just advance about a 1/2 inch to 1 inch at a time, so you don't have too many flat spots. As I said, if I was a commercial die shop, this is the rule I'd buy. It gives me the flexibility to make any shape I need because I'm only using it in small quantities. You know, I buy it 66/90, I better use it in 90-degree direction, or I got to form it and shape it. That's what the purpose of this tool is. There you have it. About 6 feet of curved rule. Is it perfect? No, but it's not bad. In order to check the diameters, what I have is I got a fixture that I made, and it fits all the BOPS machines. Mini line, 820, midline, which is a 924, 928, trans line, which is a 1224, 1228, DROs, jumbos. And so I have these little templates, and so what I do is when I curve the rule with the fixture you just saw, I just simply lay it against it to get the diameter. Is it perfect? No, these are a little snug, so I could open it up a little bit, but this is very repositionable and bendable. .44 ECT, very rigid. And strong. Here's a range of products as they stack up. Very clean and uniform. Cross corrugation. Very strong. You can even hear it. Excellent. That has the same type of pull strip as we showed here. So this carton is sealed on both ends. Simply pull the tab. Across, just like we showed.
Oh yeah. Yeah, not a good day.
And the final demonstration, same carton, single tear strip. Across. We have